Hi everyone, welcome to my session, Minimal Viable AIMS, ISO 42001, Required Documentation Artifacts for Beginners. And thank you to the Conf42 organizers for having me here today. I'm really glad to be part of this MLOps focused edition. My session is built around how ISO IEC 42001 is actually implemented and audited, not just how it is written in the standard. It's on whether an artificial intelligence management system truly exists in practice, and whether that can be proved with quality evidence. Today, when you hear me say minimum viable AIMS, no, I'm talking about the minimum set of required documentation artifacts that auditors expect to review to conclude that an organization is managing AI systems in a controlled and repeatable way. This is not about creating the perfect documentation. It's about creating clarity around business risk, ownership, change, and accountability, meaning auditable clarity, so AI systems can scale without crumbling as individuals change. And that's what I'll walk you through today, so let's get started. A bit of context on why I'm talking on this topic from this particular angle. So my background is a combination of hands-on security engineering and formal audit training. I spent over 10 years across various engineering roles, including system and solution engineering, multi-cloud, and securing containerized environments. Along the way, I worked extensively with vulnerability management, threat detection, monitoring, incident response, and what's most relevant for us today here, compliance. Over time, a large part of my security engineering role has involved supporting internal and external audits, preparing reports, gathering evidence, and coordinating improvement efforts for management self-assessment of controls, as well as ISO and SOC 2 audits. From a security engineering perspective, there is also a very practical connection to ML. For example, the Cloud Security Alliance outlines key stakeholders across the MLOps lifecycle, and security engineers are explicitly named as one of them. Among others, we are expected to plan and act on threat modeling, data protection, access control, and incident response for ML systems. I'm also trained as an ISO 27001 and ISO 42001 lead auditor through Mastermind Assurance, and I'm a certified Information Systems Auditor, CISA, exam passer, through ISA. I've worked with GRC platforms like Vanta to operationalize audit evidence, as well as with Microsoft Purview data protection solution. Outside of day-to-day work, I'm nowadays active in the community as an AWS community builder, a woman in cybersecurity VSS mentor, and a Hack the Box meetup host. I also enjoy publishing blog posts and practical walkthroughs on my YouTube channel, which is the large image on this slide. So ultimately, this talk comes directly from the intersection of all of this, making systems operable, defensible, and auditable. I'm here as someone who's had to make governance work in practice, without unnecessarily slowing teams down, while focusing on prevention, early detection, and using tactical pauses to reassess and stabilize so the business comes out stronger and more resilient. And that's the mindset I bring today. Now let's briefly level set on what an artificial intelligence management system, AIMS, actually is, and what ISO IEC 42001 brings to the table. ISO IEC 42001, moving forward I'll short it to ISO 42001, is a voluntary, certifiable international standard, published in 2023. And it's the first one focused specifically on managing AI systems at the organizational level. It doesn't prescribe models or tooling. Instead, it shifts the focus away from individual models and toward how AI systems are owned, monitored, and improved over time. It takes an organizational view of AI, focusing on how systems are governed across their life cycle, from experimentation and deployment to use, monitoring, and continuous improvement. Structurally, ISO 42001 contains 10 clauses in total. with clauses 4 through 10 defining the auditable requirements. The documentation artifacts I'll walk through are derived from the auditable clauses 4 through 10, and all clauses are supported by Annex A, which outlines 38 controls total across 9 control objectives. Importantly, all controls are mandatory. Organizations select applicable controls based on their risk profile, scope, and context. The standard follows the Plan, Do, Check, Act (PDCA) cycle, which means it's designed to mesh well with other management system standards, especially ISO 27001 Information Security Management System (ISMS). Auditors are not looking for perfection or automation everywhere. They are looking for consistency, intent, and evidence that controls are applied relative to risk. ISO standards commonly describe maturity progressing from incomplete to performed, managed, established, predictable, and eventually optimized. The goal is not to jump to the highest level immediately, but to demonstrate controlled progress over time. ISO 42001 also serves as a standalone within a broader ecosystem of AI-focused standards. For example, supporting standard ISO 22989 defines AI terminology and roles, such as providers, developers, and suppliers, which is why ISO 42001 is relevant even if you consume AI rather than building it. And supporting standard ISO 42005 addresses AI system impact assessments. From a certification perspective, audits follow a clear chain. International Accreditation Forum, 2 accreditation bodies, 2 certification bodies, 2 auditee organizations. So IF, 2 ABs, 2 CBs, 2 auditee. On IF Cert Search, the global database for accredited ISO certifications, you can look up whether an organization's certificate is still valid. Certification typically involves passing a Stage 1 documentation readiness audit, followed by a Stage 2 control effectiveness audit, and then maintaining and improving the system through annual surveillance audits within a 3-year certification cycle. Finally, ISO 42001 exists alongside other major AI governance frameworks. To highlight a few, USA's NIST AI Risk Management Framework, which provides voluntary guidance but is not certifiable. EU's AI Act introduces mandatory legal obligations for certain AI systems. And ISO 42001 here serves organizations globally to proactively and voluntarily demonstrate AI readiness through independent verification. And this is increasingly relevant because people are experimenting with ML and AI everywhere. Well-intentioned enthusiasts can unintentionally create shadow AI using corporate data on corporate devices. ISO 42001 provides a structured way to bring that activity back into visibility and control. One final note here, for copyright reasons, I'm not displaying the standard itself, as it must be purchased from the official ISO store. Instead, I'll focus on explaining why the required documentation artifacts exist and how they connect to real-world challenges. And why this matters right now? Recent industry data shows a clear pattern. A majority of organizations that experience breaches either don't have an AI policy at all or are still in the process of defining one. Even among organizations that do have policies, only a small fraction regularly audit for unsanctioned or shadow AI use. And the impact is measurable. 1 in 5 organizations has reported a breach linked to shadow AI. And when these kinds of incidents happen, the damage can be larger. Incidents involving shadow AI tend to expose more sensitive data and intellectual property, and they come with significantly higher remediation and reputation costs than traditional security incidents. At the same time, we're seeing a rise in public cases related to unfair or discriminatory AI outcomes. The AI discrimination case tracker follows legal cases where AI systems are relevant to discrimination, bias, or equality issues, particularly in areas like hiring, credit decisioning, and even arrests caused by inaccurate facial recognition systems. These cases rarely come down to a single bad line of code. Instead, they expose gaps in oversight, testing, monitoring, and accountability across the AI lifecycle. This is one of the key problems ISO 42001 is designed to address. It doesn't exist to slow innovation or block experimentation, and it doesn't guarantee that incidents can't and won't happen. What it does provide is operational clarity that strategically prioritizes response when things go wrong and gives stakeholders confidence that AI systems are being managed maturely. Over time, that translates into more efficient operations and stronger trust from customers. ISO 42001 focuses on how organizations govern and respond to AI risks in practice, and it also works alongside technical frameworks like OWASP Machine Learning Security Top 10 and MITRE Atlas, which help teams understand what can go wrong at the technical level, such as data poisoning, input manipulation, and AI ML supply chain attacks. And there's an upside beyond the risk reduction. Organizations that implement structured AI governance report tangible benefits. The ISO 42001 badge on product marketing pages draws attention, increases credibility in the eyes of prospects, shortens pre-sales and due diligence questionnaires, and help move conversations toward monetary investment quicker. As an example, several AI-powered services you may likely use today operate within certified management systems. As an AWS community builder, I would highlight ISO 42001 certified business units behind services like Amazon Textract, which is ML service that extracts data from scanned documents, then Amazon Transcribe for speech to text, Amazon Bedrock for building Gen AI applications, and Amazon Q Business as an enterprise AI assistant. As a small side quest, you can access this ISO certificate through free service AWS Artifact. Grab the certification number and then verify it yourself on IIF search. It takes just a couple of minutes and it's a great way to see how this works in practice. Feel free to reach out to me on LinkedIn afterward and tell me how it went. I'm genuinely curious who actually tries it. Ultimately, the long-standing case for standardization still applies to AI management systems. As AI systems scale, the cost of not knowing, not measuring, and not improving grows faster than the cost of proactive planning and putting the right controls in place. Now zooming into the artifacts. In lead auditor training, the requirements of ISO 42001 are often distilled into required activities and required documentation artifacts. Today, I'm focusing on the documentation side, and you can think of these 16 items on this slide as 16 points where clarity is required across the auditable clauses 4 through 10. 4. Context of the organization. Clause 5 focused on leadership. Clause 6 on planning, 7 support, 8 operations, 9 on performance evaluation, and 10 focus on improvement, or CLPSOPI as an acronym. So context, leadership, planning, support, operations, performance evaluation, improvement, CLPSOPI. Each one exists because without it, something important tends to fall apart. As I go through them, I won't show full documents today since they can get quite lengthy. Instead, I'll highlight their significance from an audit perspective and connect each one to the real-world problems teams run into. Fact 1. AI MS Scope, Clause 4.3. Defining scope answers a very simple questions. What exactly are we covering? This artifact exists for one reason, to make sure everyone understands which AI systems are governed, which are not, who is responsible before something goes wrong. This artifact depends heavily on two things: organizational context and the AI use cases this specific organization identified. Without those, scope becomes guesswork. In MLOps, this problem usually appears the moment experimentation gets popular. A model starts as a notebook, someone connects it to a pipeline, and suddenly it's influencing final workflows before anyone has defined whether it belongs inside governance or not. A very public example of this kind of situation involves engineers pasting proprietary material into unmanaged AI tools of their personal choice during daily work. Rarely, let's say, there is malicious intent. Often, it's just an attempt to speed up repetitive tasks or analyze large spreadsheets with AI, so it doesn't look like an attack at all. Organizations need to clearly define which AI tools are approved for corporate workflows, what data can be used, where experimentation ends and production begins, and what happens when acceptable use rules aren't followed, because without that clarity, governance only exists on paper. Very often, individual unmanaged AI accounts come with default data control settings that allow user content to be used for model improvement, sometimes phrased as improve the model for everyone. These settings may not align with corporate governance expectations if they're used on business devices or with company data. That's why many organizations prefer centrally managed enterprise plans for tools like ChatGPT, Copilot, Claude, and others. These enterprise plans typically include stronger governance features, role-based access, audit logging, custom data retention, content safety guardrails, and centralized administration, making it much easier to align with corporate security and regulatory requirements. Without a clearly defined scope, teams naturally drift toward whichever tool feels most convenient, even if its default governance model doesn't match organizational goals. In many companies, acceptable use guidelines even recommend avoiding unmanaged personal accounts on corporate equipment, so it's always worth checking with internal points of contact before self-choosing an AI tool for work. We've also seen real infrastructure issues where lab environments were exposed externally or experimental tooling ended up reachable from production networks. These weren't sophisticated AI attacks. They were ordinary infrastructure mistakes applied to very powerful systems. Misconfiguration, exposure, drift, and unowned pipelines are still more common than advanced adversarial techniques. From an audit perspective, this is exactly where the scope artifact helps. It forces explicit scoping of which ML tools may run in production and which environments require authentication, logging, and approvals. Exposures involving platforms like Jupyter, Kubeflow, or MLflow are still common, and sometimes a CVE appears where everyone internally says, "Oh, this clearly wasn't checked. I can see how this was supposed to stay in the lab." Clear scope boundaries help prevent these situations from quietly reaching production. Defining an AI policy sounds abstract at first, but in practice it can answer a very close to home question. What approach and what high-level rules does this specific business support when working with AI systems? Without a clear policy, every team ends up inventing its own workflow. One team retrains weekly, another deploys directly from notebooks, and someone else exposes an endpoint with default settings because nothing explicitly said not to. From a governance perspective, this inconsistency becomes a risk very quickly. This artifact depends heavily on demonstrated leadership commitment and organizational strategy. The policy is commonly approved by executive management because it defines the organization's stance on responsible AI and how risk is handled at scale. We see stricter AI policies frequently introduced just after incidents involving sensitive data exposure or regulatory pressure. The technology itself is rarely the sole issue. Gaps in governance, oversight, and communication are often at the center. Policy helps establish shared expectations across teams and demonstrates accountability, which regulators increasingly expect, especially under frameworks like GDPR, focusing on personal data protection. From an MLOps perspective, this artifact actually makes engineering easier. It can give you the authority to say, these tools are approved here, these defaults are forbidden, and these models require additional approvals. Engineers already know insecure defaults are dangerous, but without policy backing, they often lack the mandate to enforce changes. We are now in clause 6, planning, to CLPE planning. More precisely, clause 611, planning for risks and opportunities. The question here is, what actions will we take once we know specific AI risks exist? We know this pattern. Risks get discussed, even documented, but nothing changes operationally. Nothing changes if nothing changes. Nothing turns into backlog work on the board or real controls because nobody translated them into engineering tasks. This artifact exists to drive that planning and translation into action. Each risk or opportunity must have an owner, a decision, and a concrete next step, such as implementing bias reviews or developing a resource plan to address insufficient resources for AIMS activities. In practice, this enables proactive risk handling and demonstrates that risks are acted upon, not just identified. Before teams can control AI risks, they need a governance structure that actually works across leadership support, resources, training, and clear ownership. And this document tracks planning for exactly that. It also reminds us that governance isn't only about preventing problems. Organizations use this artifact to pursue opportunities as well. Plans for improving reputation, accelerating market entry, or reducing client-led queries and questionnaires by demonstrating mature AI governance, such as through ISO 42001. 612. A risk assessment process. Risk assessment in ISO 42001 is fundamental for identifying and evaluating risks associated with AI systems. These risks may include harm to individuals, bias, lack of transparency, safety issues, misuse, or unintended public impact. The assessment allows the organization to prioritize risks based on likelihood and impact. Results of risk assessments directly inform risk treatment decisions and the selection of Annex A controls. Without a proper risk assessment, the effectiveness of the AIMS cannot be demonstrated. What this artifact answers is simple. How do we evaluate AI risk consistently before models move forward? This process depends on two foundations: a clearly defined scope and agreed methodology for risk criteria. Without those, risk decisions easily become subjective. One team treats a model change as a low risk, another blocks deployment entirely, and suddenly governance feels inconsistent rather than helpful. A repeatable risk assessment process changes that. It introduces a common language: impact, likelihood, stakeholder review. Some model updates are evaluated using the same logic across pipelines. The purpose here isn't to predict every possible outcome. AI risks evolve as models are retrained, reused, or deployed in new contexts. What auditors want to see is a structured way to evaluate risk before promotion, not only after an issue reaches production. This becomes even more important because model artifacts aren't just data. They behave like executable components, serialization formats, dependencies, and retraining workflows introduce risks that traditional teams might overlook. When teams treat promotion as just another commit, vulnerabilities, language toxicity, and bias can slip through unnoticed. 613 artifact covers AI risk treatment and statement of applicability. What you're seeing on the right is a small example from an SOA, specifically Control A55, which looks at societal impact of AI. And when people hear that phrase, societal impact, it could sound abstract, but in practice it becomes very concrete very quickly. First, it implies environmental impact. Modern models don't just live in notebooks. They run on infrastructure, consume energy, and create a real carbon footprint. Organizations are starting to track that life cycle impact, especially as going green, sustainability, environmental, social, and governance (ESG) regulations and reporting standard expectations evolve. Second, implied economic impact. This isn't only about job displacement. It's also about who gains access to new tools, who gets included, who excluded, and how organizations support reskilling or responsible automation decisions. Third, governance and recourse. A system makes a decision. Can it be truly understood or challenged? Explainability and traceability are no longer just technical nice-to-haves. They're becoming core audit evidence. Then there's health and well-being. That includes not just safety issues, but subtle harms, like stress caused by automated decisions or biased outcomes that could affect access to services. And finally, cultural cohesion and values. ISO 42001 brings fairness, diversity, and rights into scope in a way that can be audited, not just discussed. Clause 6.2 AI objectives and plans to achieve them. Very often, this section actually lives inside the broader AI policy because it translates leadership intent into something teams can track and improve over time. The core question this artifact answers is: what targets are we aiming at with our controls and MLOps practices? In many organizations, monitoring exists, dashboards exist, alerts exist, but just in case they are undocumented or not disseminated and openly discussed among personnel within AIMS scope, it can remain unclear what success looks like. ISO 42001 requires objectives to align with the AI policy and, where practical, to be SMART, meaning specific, measurable, achievable, relevant, and timely. This means things like reducing model-related incidents, detecting drift faster, or ensuring secure patching timelines for infrastructure supporting ML business units. This also creates alignment across levels. Top management sets direction, and teams translate that into operational goals tied to pipelines, deployments, logging, and monitoring. From an audit perspective, this artifact is powerful because it converts intention into proof. Instead of saying, we care about responsible AI, that is our objective, you must show measurable target and a review cycle. That's how continual improvement becomes concrete and visible over time. We're in clause 7 now, support, and more precisely 7.2, artifact on personnel competency. Personnel competency is one of those artifacts that could sound administrative and preachy, but in practice, it directly addresses risk at the human layer. The core idea is simple. People operating AI systems need competence that matches the risk they influence. And that does not mean everyone becomes a security expert. It means role-appropriate awareness is intentional and documented. This artifact depends on clearly defined roles and responsibilities and understanding of training needs. Competency can span areas like MLOps engineering, bias awareness, data protection, and AI incident handling, tailored to how each role interacts with AI systems. From an ISO 42001 audit perspective, What matters is evidence such as training records, certifications, or workshops. The goal isn't perfection, it's showing that competence is planned, tracked, and aligned with AI life cycle and roles and responsibilities. 7.5 Artifact on all documented information for the specific organization. Artifact can answer what documentation do we actually need to operate our AI systems safely beyond what the standard explicitly lists. Clause 7.5 gives organizations flexibility. It recognizes that real MLOps environments generate critical knowledge that doesn't always fit into predefined standards. Things like model release notes, prompt updates, vendor change tracking, or pipeline hardening steps often start informally, laying in Slack DMs across emails or kept just in someone's brain. The risk is that when documentation lives only in tribal knowledge, businesses tend to lose track. Reproducibility suffers, and after staff changes, nobody knows why a model behaves the way it does. This artifact legitimizes documenting what teams already rely on, making sure critical operational knowledge survives beyond individuals. Auditors will look for evidence that the organization recognizes what documentation is necessary for its own maturity level and AI complexity, and that those documents support consistent operation. Clause 8 Operations and 8.1 more specific on operational documentation. This artifact exists because the planning we had in Clause 6 doesn't prevent incidents by itself, execution does. Teams may define change management steps, approval workflows, or rollback procedures. But if those steps aren't documented and executed consistently, unexpected delays can happen, and recovery may be costlier and take longer than expected. The Clause 8.1 and operations in general aims to ensure that activities like change management, testing, impact assessments, and rollback procedures are not just defined, but actually operationalized and carried out as planned. And auditors look for evidence that operations are repeatable and that recovery actions are prepared before deployment. Now, a risk register artifact. Without a risk register, ML risks tend to scatter over time, and teams lose visibility. The same issues get rediscovered repeatedly because there is no ownership over the full risk picture. The AI risk register creates a single source of truth, and only evaluated risks are recorded here after going through the risk assessment process. A common MLOps example is data drift. Teams might notice performance dropping, but without a central register, nobody tracks whether mitigation actually worked or who is responsible in the next quarter. The risk register solves that by turning individual observations into organizational memory. Auditors want to see that the risks are not only identified but actively managed over time. 8.3 Specific plans for AI risk treatment. Once a risk is identified, how do we make sure something actually happens next? And what happens to it? Is it transferred, mitigated, or accepted? Many are good at identifying risks and even planning mitigations, but follow through is where things often break down. An AI risk treatment plan focuses on that exact pinpoint. It links directly to the risk register and the statement of applicability, defining which controls are applied, who owns them, and when progress will be reviewed. 8.4 AI System Impact Assessment Artifact. Models can perform exactly as designed, but their broader real-world impact isn't always evaluated holistically. Recommendation engines, decision support tools, or automation workflows may introduce social, ethical, or operational consequences that only appear once systems scale in real-world environments. This artifact exists to make those effects visible early, and it complements risk assessments by focusing on outcomes and potential harm. It documents intended use, affected stakeholders, and known limitations, while also encouraging teams to think about wider areas like environmental footprint, economic impact, explainability, and long-term well-being. Auditors here want to see that organizations considered impact deliberately and documented their reasoning. Clause 9, performance evaluation now, and 9.1 on results of monitoring and measurement activities. Organizations start by defining what needs to be monitored, usually through clear key performance indicators such as model accuracy, response time, fairness indicators, or compliance metrics. Just as important is defining how the data is collected, how often is it reviewed, and who is responsible for analyzing it. Without clear ownership and a defined review cadence, monitoring becomes passive data collection rather than effective governance. Once data is collected, Clause 9.1 requires analysis and evaluation. Teams compare actual performance against objectives, identify trends or emerging risks, and feed those insights back into decision-making. This creates a continuous feedback loop in which monitoring drives tangible improvement. Auditors also look for documented evidence. Monitoring results, analysis outputs, and performance reports need to be retained, version controlled, and accessible for review. The goal is not to create more dashboards or more reporting that is not actionable. It is to show that monitoring leads to informed action and measurable progress across the AI lifecycle. 9.2 Internal Audit. As pipelines evolve, responsibilities shift. People move on or grow into new positions. Retraining schedules shift and controls can get bypassed temporarily. And over time, the documented process no longer matches reality. The gap is what internal audits are designed to surface early. This artifact depends on all implemented AIMS documentation and operational records. And auditors look for evidence that controls are reviewed periodically, findings are tracked, and improvement actions follow. Internal audits act as an early warning system. They identify weaknesses before customers, external auditors, or attackers expose them. The audit results support management review and corrective actions. Internal audits are essential for maintaining the effectiveness of the AIMS over time, and they also prepare the organization for external certification audits. 9.3 Management Review. Management review records demonstrate that monitoring results, internal audit findings, and AI objectives are actively reviewed by leadership. These discussions lead to decisions about priorities, resources, and strategic direction. This is how AI governance moves from reactive to strategic and intentional. Top management carries responsibility for ensuring the AIMS achieves its intended outcomes, which means understanding trends like drift incidents, recurring findings, or performance changes, and deciding what needs to adapt next. Management review results also feed directly into corrective actions and continual improvement. They ensure AI governance stays aligned with business goals rather than operating as a siloed compliance exercise. And the last documentation artifact from me today, from Clause Improvement, 10.2 Nonconformities and Corrective Actions. A nonconformity simply means something did not happen the way that was planned and documented for the management system. Maybe a control was skipped, monitoring results were not reviewed, or deployment moved forward without the required approval step. The critical part is not the mistake itself, it's how the organization responds to it. Clause 10.2 focuses on structured response, and it closes the loop of the Plan, Do, Check, Act. When a nonconformity is identified, the auditor documents the gap and the supporting evidence. A mature organization then takes ownership. It analyzes the root cause, evaluates the impact, and defines corrective actions so the issue does not repeat. Not following up on the agreed upon timelines for fixing, or fixing symptoms that appear on the surface without addressing the root cause, tends to lead to repeated failures, and in some cases may be interpreted as organizational negligence. You'll often hear auditors distinguish between minor and major nonconformities. A minor one is typically an isolated gap, such as a missing approval record, while a major nonconformity signals a significant breakdown in the management system, for example, missing processes or an entire clause not being implemented as expected, or repeated failures that suggest systemic negligence. Major findings can delay certification or even suspend an existing certificate until corrective actions are verified. Ultimately, auditors expect to see ownership, timelines, and proof that actions were implemented. If corrective actions from a previous audit are ignored, the issue may escalate into a major nonconformity, signaling a deeper breakdown in the management system and potentially impacting certification status. And with that, we wrapped up all 16 required documentation artifacts. Something I'd highlight as a key takeaway right now is this. When organizations start implementing this minimum viable set of AIMS document artifacts, they tend to see disproportionate benefits right away, and information gaps are brought to light, so effective discussions and actions are sparked. Boundaries between experimentation and production becomes visible. Releases become safer because fewer assumptions are left undocumented. And when something goes wrong, the response is faster because at any time, day or night, stakeholders know the documented information already exists, where to find it, and how to conveniently follow the outlined steps. Another important lesson is that advanced models rarely cause problems by themselves. Most issues are governance failures, missing ownership, missing traceability, and missing feedback loops. Problems emerge when assumptions go unchallenged, and no one can answer with certainty simple questions like who approved the change, what data was used, or whether the system is still behaving as intended. A third lesson is that ISO 42001 works best when integrated into existing practices, not after the fact and siloed as a checkbox exercise. Adapting existing processes across product planning, risk management, audits, and security reviews, and extended to cover AIML specific risks works best. One thing that comes up repeatedly is the importance of people and leadership. Training matters not just for engineers, but also for product owners, sales, decision makers. Executive sponsorship of ISO 42001 certification efforts is often the difference between AI governance existing on paper and actually being followed in practice, with evident and positive behavior changes for the organization and its people. There's also a very practical fact worth stating clearly. Certification is almost never free. It requires time, attention, and budget, and it carries other opportunity costs. That's why organizations that succeed tend to take a risk-based approach, prioritizing controls proportionate to this specific business impact, instead of trying to boil the ocean all at once. Finally, the strongest takeaway is this. Organizations that approach ISO 42001 as a strategic investment, not just a compliance exercise, see real returns. And these include improved customer trust, better internal clarity, smoother audits, and more confidence when scaling AI systems. I'd like to finish by thanking you all for being here, and also the organizers for the warm welcome, as well as the sponsors and everyone else supporting this event behind the scenes. I welcome your feedback, and I'd be glad to continue the conversation. Feel free to connect with me on LinkedIn, and hopefully I'll have the opportunity to share more insights with you at the future edition of the Conf42 conference. Greetings from me. Until next time.